Okay, so I picked this problem out because you have to use the law of sines and law of cosines. And it's going to be a bit of a bear. So I just set it up in class and I said, you don't have to solve it. But in case you're curious, I'm going to try and solve this all the way through with all the gory math and everything in it. I wouldn't put something like this on a test, but in case you want to see how these things work out, I'll work it out for you. So the first thing I'm going to do is do some trigonometry. I'll be right back. So the first thing I did was draw this triangle in green. That side of the parallelogram is parallel to the other side, so that this right here is going to be F1. And then I knew that this angle was phi, and so this interior angle is just pi minus phi, or 180 minus phi. And by adding all three angles inside that green triangle, added up to pi, you get that angle on that other side is phi minus theta. Okay, so we are just going to use law of sines and law of cosines and try to follow our nose and see if we can solve for FR and for theta in terms of everything else. I'll set up all the equations and be back. Okay, so as we went over in class, the law of sines is the length of one side over its opposite angled sine will all be equal. So F1 over sine theta equals F2 over sine phi minus theta equals FR over sine pi minus phi. And remember in class I also said that the law of cosines is like the Pythagorean theorem but corrected. So if that interior angle pi minus phi was 90 degrees, we would have F1 squared plus F2 squared equals FR squared. But because it's not 90 degrees, you have this correction of plus 2 F1 F2 cos of that angle. Actually, I think it's minus. Let me go check and come back. So yes, I had that wrong. This should be minus. Okay, so that's where I left it in class, and I said if you were good at finding the formulae for sine of a plus b and cosine of a plus b, you could figure this out. So let me go look that up, come right back, and show you what those are. So actually, I didn't look it up. I just derived it real quickly using complex variables. One day, remind me to show you how to do this. And basically every time I need to know a double angle formula or cosine a plus b, I just redo the derivation. But anyway, here we go. This is cosine of a plus b right here, and this is sine of a plus b right there. And so what we want to know is we want to know what sine of phi minus theta is. We want to know what sine of pi minus phi is. And we want to also know what cosine of pi minus phi is. I'll plug these into the equations above, and I'll be right back. Okay, so I did sine of phi minus theta. That wasn't very useful. It still gave this complicated thing. However, sine of pi minus phi turned out to cosine pi, which is minus 1, times sine of minus phi, which is minus sine phi. So that all turned out to just sine phi. And cosine of pi minus phi turned out to cosine pi, which is minus 1, times cosine of minus phi, which is cosine phi. So that ended up being minus cos phi. So those two will be useful. So we'll plug these two into the equations above and see what we get. So plugging into the law of sines, you get this. F1 over sine theta is FR over sine phi. And plugging into, excuse me, law of cosines, you get this. FR squared is F1 squared plus F2 squared minus, but the cosine pi minus phi is minus cosine phi, so that comes out to a plus 2 F1 F2 cosine phi. And so remember, the unknowns that we're trying to find are FR and theta. So there we go. We can solve equation 2 right away for FR, and then we can get theta from equation 1. So let me write that all out for you. So here's the final answer. Fr is the root of f1 squared plus f2 squared plus 2f1 f2 cos phi, and f1, f2, and phi were given. And once you get fr, you plug it into that second equation, and sine theta is f1 sine phi, both given, over fr, which you just solved. So that's it. It's kind of an ugly answer to an ugly problem.